Okay, welcome back to our next video lesson. Today we're going to be talking about the sums of arithmetic and geometric series. Sometimes they're referred to as the partial sums. So we have a little bit of new terminology here. The first thing we want to look at is what S sub n is. S sub n is the sum of the first n terms of a geometric series. In other words, if we're talking about S sub 10, we're talking about the sum of the first 10 terms. Sum, of course, meaning add. There are two formulas for these partial sums of series. The first one applies to our arithmetic series. Okay, and so good news and bad news. This lesson is pretty much formula driven. The bad news is there's two more formulas that you have to know. The sum of the arithmetic sequence is S sub n equals n times the quantity t plus 1 plus t plus n, all divided by 2. So if you notice in this formula, in the arithmetic series, we're required to know a little bit of information about the sequence. We're required to know the first term, t sub n, the first term, t sub 1, and the last term, t sub n. So we may be given that information, we may have to locate that information, but we know how to do that from previous lessons. For a geometric series, the formula is a little different. To find the sum, the partial sum of a geometric series, the formula is S sub n equals t sub 1 times the quantity 1 minus r to the n over 1 minus r. This only requires us to know what t sub 1 is and what r, the common ratio, is. Okay, so let's first take a look at some arithmetic series. Okay, so let's look at the first series here. It says find the sum of the arithmetic series. In this first example, we're pretty much given everything that we need to know. So let's recall the formula. The formula is S sub n equals n. And I do this often. I keep writing the formulas over and over again, especially when I'm trying to memorize them. T plus 1, t sub 1 plus t sub n all over 2. So the good news is we're given all the information here, so it's a matter of just plugging in the numbers. Where these formulas came from is a little bit complicated, so we're not going to get into how the formulas were derived. But if you're interested, you can go ahead and look it up in your textbook, and it tells you how the formulas were derived. So let's first say n is 100. We were told that in the problem. So what we're doing is we're finding the sum of the first 100 terms. So if I wrote out 100 terms of this sequence and added it up, this would be the sum. Parentheses, t sub 1, which is 17, plus the 100th term, which is the last term, 215, all divided by 2. Okay? Now, if you want to make your math a little simpler, you can divide the 100 by 2, and then you'll probably need a calculator. So that's the same as 50 times the quantity, and then I'm going to go ahead and add 17 and 215 to get 232. And then I'm going to go ahead now and just go to my calculator and do 50 times 232. So the answer is, oops, sorry about that, 11,600. So this is a quick way around actually writing out 100 terms and adding them up. Okay, let's take a look at the next problem. Okay, remember we talked about the sigma, which means the sum. So basically this says we're summing as n goes from 1 to 50 of 2n minus 1, which means we're summing the first 50 terms of this sequence. Now remember what our formula was asking us. It was asking us for t sub 1 and t sub n, and t sub n would be the last one. So we're actually going to need to find t sub 1 and t sub 50 here. Okay, and we know this is pretty simple. We just plug 1 into the formula to find t sub 1. So it's 2 times 1 minus 1. T sub 1 is 1. And then we have to find t sub 50. So it's 2 times 50 minus 1 to get 99. So our first term is 1 and our last term is 99. Now we're ready to just go ahead and plug it right into our sum formula. S sub n, in this case n is 50 because we're summing the first 50 terms. So we'll say S sub 50, can hardly tell my S's from my 5's. S sub 50 is 50 n parentheses the first term plus the last term all divided by 2. Okay? So basically, doing this, I can cancel the 2 and the 50 to make 25 and add the 1 and the 99 to make 100. And 25 times 100 is, am I making you dizzy yet? Is equal to 2,500. So that would be the sum of the first 50 terms of that sequence. Or I should say that series. Okay, not bad so far, huh? Okay, let's look at the last one. This one's probably going to take the most work, although it's not really that complicated. Okay, remember what I said. We needed to know the first term, the last term. But the problem with number 3 is we don't know n. I do not know how many terms are in this sequence. This is very similar to a problem that we did in the homework when we did the arithmetic sequences. Let's go ahead and write the formula, not for the summation, but for the sequence itself. Okay, remember our good old formula. Any t sub n equals t sub 1 plus n minus 1 times d. N minus 1 times d. Okay, and let's find the formula. So first thing we need to identify is what t sub 1 is. So t sub 1 is 50 plus n minus 1. And my common difference here is, what am I adding every time? Negative 2. Okay. Prettying up this formula by distributing the negative 2. I get 50 my t sub n back over here. Minus 2n plus 2. Which, go ahead and yields me 52 minus 2n. Okay. Now, we've done this in the homework before. This is the last term. I need to find out what n is for that term. So what I do is I plug the 10 into my formula for the term. So 10 equals 52 minus 2n. And then I go ahead and solve this for n to get n equals 21. Okay, now I have everything I need for my summation formula. N being 21 means I'm looking for the sum of the first 21 terms. So n sub 21 equals 21 parentheses t sub 1, which is 50, first term plus the last term divided by 2. And so I don't really want to divide 21 by 2 now, because that's not so pretty. So I'll add the 50 and the 10 to make 60 divided by 2. And then I'll just go ahead and cancel the 2 with the 60 instead of with the 21. So I have 21 times 30. Oops, almost running out of room here. And 21 times 30 is 630. So the sum of all of those terms would be 630. Okay? That's basically as hard as it gets for arithmetic sequences or arithmetic series. So now let's jump down and let's talk about the geometric ones. Okay, this math is a little bit more complicated, and you are definitely going to need a calculator for this math, because if the geometric sequences grow big quickly and then we start adding all those big terms up, we're going to get even bigger numbers. So geometric series grow even more rapidly than geometric sequences. Okay, so once again, this first one is going to give us pretty much everything we need for the formula. So let's review our formula. Our formula is, that's an S, not a 5, NES sub n equals T sub 1 minus, I always put my r in parentheses just in case it's negative, it's got to be in parentheses, 1 minus r to the n over 1 minus r. So we pretty much have everything we need here. Okay, so plugging into my formula, S sub n equals my first term, which is 1. That's nice. That makes the math a little simpler. 1 minus, and here, especially when you go to the calculator, you have to make sure that you put negative 2 in parentheses, negative 2 to the power of 10, close my parentheses, divided by 1 minus r. So divided by 1 minus negative 2. So let's look a little bit how we're going to simplify this before we put it into the calculator. I don't care about this 1 out here, right? So when we're putting things in the calculator, we need to encase our entire numerator in parentheses. So it's 1 minus. Now do not cancel these minuses. Do not make that minus minus a plus, because remember with PEMDAS the exponents have to come first. To the power of, so we use our caret, 10, all divided by, and then instead of typing in 1 minus negative 2, I'm just going to make that 3. Okay, so go ahead and if you need to, pause the video, put this in your calculator and see what you come up with for an answer. Okay, so by putting in the calculator, you should have come up with negative 341. Okay, so if you're struggling a little bit with this calculator input, we'll talk about it a little bit more in class. Negative 341. So see, it's just a matter of plugging the right pieces of the puzzle into your formula. Okay, let's look at number 5. Okay, number 5 means we're summing, that's that sigma, 1 to 10, which means we're summing the first 10 terms. So n is going to be 10. R is my common ratio. If you have to write out a couple of terms in the sequence to see the common ratio, you can, but that right there is your common ratio. Whoops, so our common ratio, R, is negative 1/2. Okay, and we also need to identify T sub 1. So T sub 1 equals, and to find T sub 1, I'm just going to erase this mark I made here. To find T sub 1, all I have to do is plug 1 for n into my formula. So it's negative 1/2 to the 1. So my T sub 1 is also negative 1/2. Okay, now we're ready to go to our formula. The sum of the first 10 terms is equal to T sub 1, which is negative 1/2, parentheses, 1 minus R, which is negative 1/2, to the 10th, close that parenthesis, all divided by 1 minus R. Okay, so now there's a lot going on in your calculator input here. So a couple of things that help a little bit with the calculator input is actually changing fractions to decimals. Okay, so I'm going to go ahead, scroll over here a little bit. I'm going to go ahead and change negative 1/2 to negative 0.5. Now, we're going to have to, when we put it in our calculator, encase the whole numerator in parentheses. So it's going to be parentheses negative 0.5, and then another parentheses 1 minus, and then another parentheses 0.5, oops, negative 0.5, I should say, negative 0.5, close parentheses, I have to tell my parentheses here, to the 10th, okay, and now I have to close this parenthesis and then close my very first parenthesis. So we got a lot of parentheses going on there. divided by, and then 1 minus negative a half becomes 1 plus 1/2, which is 1.5, divided by 1.5. I guess I failed to mention earlier that even though these things, I say they grow really fast, they also shrink really fast. So this is actually going to be a very small number when you put it in your calculator. Okay, so pause the video, try to put this in your calculator, and then come back and see what the answer is. Okay, do you think you have the answer? It's equal to, and we're going to go ahead and leave this to 3 significant digits. So it's negative 0.333. Negative 0.333. Okay, hope you got it. Okay, what we're going to do now is we're going to take a break from this video, and then we are also going to be doing 11.6 on a new video.